What we're doing here is we're going over the first outcome, the B objective, basically making sure that you can understand some basic chemistry concepts as it relates to anatomy and physiology. Number one of these is being able to differentiate between matter and energy and between the types of energy, potential and kinetic. Okay. So first we're going to do is we're going to define energy. And energy is simply the ability to do work. Okay. That's all energy is, the ability to do work. Work is a force times distance. So if you had a block here and you applied a force to it, 100 newtons, and you moved it 1 meter here, you have done 100 newton meters of work. So basically you just multiply the force and the distance, and that gives you work. What this also says is if you apply that force, 100 newtons, and it moves 0, you've done no work whatsoever. Okay. And then we have force. The definition of force is a mass times acceleration. So if you have this block and let's say it weighs 1 kilogram, and you accelerate it at 2 meters per second squared, the force is 1 kilogram times 2, or 2 kilograms meters squared. Meters per second squared. Okay. Or 2 newtons. 2 newtons, that's all. Okay. So that's energy. I mean, that's really energy. Now, there's a bunch of types of energy that we don't have to worry about. We just want to know the basics. We want to know the basics, and this is the very basic of itself. Now, types of energy that we want to know about, the two types of energy that we want to know about are potential and kinetic. Okay, there's energy. One is potential. And basically this is stored energy or energy due to a property. Okay. Property or position. That's what, or position. Okay. So that's what it is. Typically here, stored energy is a definition you're going to see most often. I think that's one you're going to see in your textbook as well as stored energy. But if you have something hanging by a rope, if you cut the rope, it's going to use gravitational energy to do some work. If you have your arm, resting and it falls, that's going to do it. A dam has positional energy. Electrical charge is a property, and it has potential energy, potential charge. So there's a bigger definition than that, and the simplest definition is stored energy. So you know some types of stored energy. Okay. Your batteries, okay, like your cell phone. You charge your cell phone at night, and then when you unplug your cell phone from the charger, it still works. It's because it's using the energy that was stored in the battery to power the phone. Gas in your car, okay, is a stored energy. Okay, you use the gas. You actually combust the gas to provide you the propulsion to go forward. Okay. In our bodies, we have this thing called ATP. That is a stored energy. Whenever you need to do some type of chemical reaction inside of the body, that requires energy. You usually use ATP in order to allow that to happen. And the classic physics is the rock on the hill. And we'll use that to illustrate the relationship between potential and kinetic energy. Okay. So those are 4 examples of potential energy itself. So just remember, potential energy is stored energy. Then we have kinetic energy. And basically this is of motion or objects in motion. Okay. And they are directly related, potential energy and kinetic energy. And we're going to show you how they're related right now. And so what we're going to do is we're going to draw a hill. We're going to draw a hill. Okay, so we've got a hill. Okay. And at the top of this hill, we're going to put a boulder. Right there. And right now, at the top of this hill, the potential energy is at its maximum. I'm not going to give you a number. Numbers are important. Concepts, what's actually important. So at the top of this hill, the potential energy is at max. And since it's not moving, the kinetic energy is minimum. Okay, is at its minimum, the lowest point. So basically 0. Okay, but I'm just going to say minimum. So we got max potential energy, minimum kinetic energy. So let's say one day you decide to come up, climb this hill, and you're going to give it a push with a force. And what that's going to do is it's going to cause the rock to roll down the hill. Like this. Now, when we are at the bottom of the hill, the rock is going as fast as it can, the kinetic energy is the max, and the potential energy is at the minimum. So, when the rock is in full motion, as fast as it can go, the kinetic energy is the maximum. The potential energy is at the minimum, or almost 0. What this shows us is that we don't just make the kinetic energy from nothing. It just doesn't appear out of nowhere. What has happened is that I have taken this potential energy and I am converting it into kinetic energy. Okay, until all the potential energy is gone and it has been totally converted into the kinetic energy. What that shows us is as we go down through here, this is the trajectory of the rock, the potential energy will decrease as the kinetic energy increases to a maximum setting. Okay, you can't have more kinetic energy than potential energy can give you unless you act on it by an outside force. Okay, it took you an outside force to set it in motion, but once you set it in motion, the potential energy started to be converted into the kinetic energy itself. Which brings us to an important concept when we're talking about physics and energy in general. It's called the conservation of energy and mass, and it states that energy cannot be created or destroyed. Okay, it can be converted. From one form to the other. I'm going to say one type to another. Okay. Example of this is your car. So when you put gas in your car, you start your car and you drive to where you need to go. And so what allows you to move, what allows you to go forward, is the conversion of gasoline to the power that will actually spin the rotors on your wheel. Okay. Now, you're taking gas, which is a liquid chemical energy, and combusting it to give you another type of energy. You are converting the energy from one type to another type. Okay. What the conservation of energy and mass basically says is that when you do this, and it's a thermodynamic thing as well, when you do this, what you're going to do is you're going to lose something as heat. So now every one of you has felt your car after you've driven it. It's hot. Okay. And what that is it is the loss of energy while you convert it. Okay. What the takeaway here is you can't make energy from nothing. it has to be converted from some other sources. Okay? All right, so that's energy. So we've gone through kinetic energy, we've gone through potential energy, we've gone through the definition of energy, we've gone through work, force, and the basic definition of energy itself. So now we're going to look at matter. So matter is anything that has mass. Okay, we're going to put a little red ring around that, red box around that, and volume. So another way to think of volume is anything that takes up space. Okay, anything that takes up space. Okay, so matter has several states. Matter has several states. We have our solids. We have liquids. And we have gases. Now, you can go from a solid to a liquid. And this is called melting. Okay. You can go from a liquid to a gas through vaporization. Now, if I go one way, I can go the other way as well. A gas can become a liquid through condensation. And a liquid can become a solid through freezing. Now, also, we can go from solids to gases and gases to solids. A solid can become a gas through a process called sublimation. Okay. And a gas can become a solid through a process called deposition. Let me just write that over. That was terrible. Basically, you just need to do the D, deposition. Deposition. So those are the states of matter, and those are how we go from the different states of matter. Now we need to talk about this thing called mass. Mass, and then we'll be done. So mass is how much stuff is in an object. Okay. Now, a lot of times we use weight as an equivalence for mass. A lot of times we will say how much mass is how much weight it is. And for us, yeah, we can say that. It's pretty safe to say that. However, it breaks down when we start to throw in gravity, changes in gravity. But we're not going to be changing gravity in this class. But ideally, weight is the pull of gravity on the mass. Okay, so if you increase gravity, you're going to increase the weight, but you haven't increased the mass. Okay, so if I have something that weighs 1 kilogram on Earth, and it's 1 kilogram because that's what weight is, and if I take it over to the moon, put it on the moon's got about 1/6 the gravity of Earth, so it's going to be weighing 600 grams. So the mass hasn't changed, but the weight hasn't changed. Okay, but again, I don't need you to get all caught up in that. Mass is just remember, mass is how much stuff is in an object. Weight is the pull of gravity on a mass. Now, if you want to get really, really technical about what mass is, if you remember the equation for force, so force equals mass times acceleration. Now, if you want to figure this out, basically you just have to rearrange this. You have to get mass by itself. So force over acceleration equals mass. So that's what you'll do. So if I have something that is 100 newtons, a force of 100 newtons, and it's accelerating at 2 meters per second squared, okay, the only mass that can do that is 50 kilograms. Okay, and so how you would solve that is you just take this 100 divided by 2 is 50, and you use the you use the units as they apply. So that's the actual, if you want to get down to the nitty gritty, you want to figure out mass, there you go. It is the resultant effect of a force accelerating something at a certain speed. In this case, 100 newtons, the force, is accelerating something at 2 meters per second squared. The only thing that can do that is 50 kilograms. I mean, there's nothing else. Okay. Now that's just in a vacuum, no effects of gravity on it whatsoever. I mean, that's just the way it is. Okay, so that's it. Now, what you're supposed to do is to talk about. I'm also supposed to talk about the differences between energy and matter or mass. And I have a real issue with this because there's really mass and energy are basically two states of matter. So I'm really not going to spend too much time into that. Basically, if you just remember the definition of matter, the definition of mass, how we get from the states of matter, I think you'll be fine. And just simple basic stuff. And yes, people who are going to look at this and you'll be like, it's a lot more complex than that. And I'm like, I agree with you. It is a hell of a lot more complex than that. But this is just for the introduction. This is just enough to get you by so you can understand more difficult anatomical and physical concepts. Okay, so don't try to get lost in details. Okay, the basics is more than fine. So what we're going to start doing now is we're going to actually start looking at matter, and we're going to start with the atom, and we're going to look at how atoms are built, how they interact with each other, and how they make compounds and molecules. And that is all I have for this one.